Okay. So today we'll wrap up some stuff on subsetting, and then we'll start talking about some of the basics of programming. Okay. All right. So we have some good old applications of subsetting. One is the creation of lookup tables. Okay. So let's say I've got this vector x. It's got m, f, u, whatever. Okay. It's got a bunch of f's. Has a bunch of m's, things like that. If I wanted to turn these from m and f into male and female, or either unknown or something else, we can create a lookup table. Okay. So notice that lookup itself, there's only three things in lookup. Okay. There's just male, female, and missing. Okay. And we have named each of these things m and f and u. Okay. And because of the nature of our subsetting operations, where if you feed it the same value, okay, multiple times, it's going to return that value multiple times. So here I'm going to subset this vector, which only has three things. Okay, I'm going to subset this vector lookup based on x. Okay, and so I'm going to ask it, give me back lookup where it is m, and it's going to return male. Then give me back lookup where it's f. It's going to return female. Give me back lookup where it's u, gives me missing. Give me lookup where it's f, and it returns female, so on and so forth. Okay. So because of the nature of R, where it returns duplicates without any problems when you subset, we can create basically a lookup table this way. Okay. And if we wanted to get rid of the names, because the way lookup works is that we're looking it up based on the name, we can just use unname. Okay. And we get this. It's also no problem if we have two things labeled the same thing. So here we could say m, we're going to call it known. F is also going to be called known. All right. And u will be unknown. And it has no problems, even though so I'm subsetting this based on the values in x. So it looks up in this vector what's m, known. In this vector what's f, known. And it has no problem saying known, known, even though you have two things with different names that have the same quote value. All right, there's no problem there. So this is a neat feature of lookup, okay, or of subsetting. Okay, we are using character subsetting based on names to do this. If you didn't do it this way, you'd have to do some kind of thing where you'd like find m's and replace the m's with male, and find the f, replace those with female, or something like that. Question?
Why does it for the lookup table? How come it's not in character form for the m, f, and u?
What's not in character form?
The m, f, and u.
These up here? These are names. Okay, they're when you name a vector, they appear as such up here. So let me just kind of show you here. Like I can say x is a vector where we're going to call it a is 3. Okay, and if I call x, type of x will return what? Double. Okay, and if I go attributes of x, this will be what? A list. One thing in the list will be names, and the names will be a, right? Okay, and so it's just the names of x is a, and here it just appears as such. Okay, if I turned x and I said a is first or whatever, okay, it appears this way. It's a character vector. The name of this thing is still a, and it doesn't appear in quotes because it's distinguished as such with names. Okay. But then when you go to attributes, oops, you see, oh, it's the names vector is a character vector. Okay. All right, over here we can match things in a similar way but more complex data structures. Okay, so let me. Okay, so here I have a data frame. Oh, I'm sorry. Let me. Where's my console on the right? Okay, here we go. This is what we want. Okay, so it's visible. Okay, so info is a data frame, right? And we're going to say we're on some kind of grade system. Okay. And grades is a vector, all right, just 1, 2, 2, 3, 1, okay? So the first person failed, got a poor, and as far as the fail column goes, that's true, okay? So grades are 3, 2, 1, and that's excellent, good, poor. And as far as fails goes, the first two are not fails, but the last one is a fail, okay? And so let's say we wanted, instead of having 1, 2, 2, 3, 1, we wanted to turn that into excellent, good, poor, and all of this, okay? So the way we can do this, all right, is notice I can't just say go to the info table and give me back the first row, because the first row is corresponds to a grade of a 3, right? So what I have to do is I want to say, okay, we want to look in this column that says grade. And so the way we're going to do that is we're going to use this command match, okay? And we're going to take the values in grades, and we're going to match them to info $grade, okay? So we're going to match the value in my grades vector into the column that's called grade, right? And this says, I mean, this table is very simple, so basically you're just swapping the 3's and the 1's, but it says, okay, the thing that matches the 1 is the third row. The thing that matches the 2 is the second row. The thing that matches the 3 is the first row, okay? You guys see that? All right, so with this, I can call this ID. Okay, so that's just this vector here. And then we're going to subset info based on ID. We're going to say, give me back the rows that correspond to 3, 2, 2, 1, and 3. Okay, and then so here, it gives you back 3, 2, 2, 1, and 3. And that corresponds to our original grades vector of 1, 2, 2, 3, 1. Okay, and so we're looking up the corresponding information on, you know, a data frame, slightly more complex data structure. Okay, are we okay? The mechanics of this thing. Okay, and then the other option. Okay, so one way is you can use the match thing. All right, and then another way is we can just say, you know, looking at our info data frame. You know what? The thing that we want to match against grade. Let's just rename our row names to this thing. Okay, let's just rename our row names. So that's what we're going to do. We're going to say take info $grade, and let's use those as our row names for info. Okay, and so if I do that, then info now has the row names matching this 3, 2, 1, and then I can now match. I can just subset info based on the grades vector, right? So this grades vector. So I have to turn it into a character vector because row names are characters, right? So, right, if I say row names of info, that's a character vector. So we're going to just say info. We're going to subset that as .character grades. Okay, we want those rows, right? And so it takes the numbers 1, 2, 2, 3, 1, and pulls back the corresponding rows 1, 2, 2. 3, 1. Okay, we're getting these .1 and .1 things because R wants to have unique row names, and so to distinguish, you know, because I'm pulling the 2 twice, row number 2 twice, to distinguish between this row and this row, it appends a .1 to kind of distinguish those things. Okay. So we're taking advantage of the subsetting mechanic in R to, you know, create lookup tables. Yeah, question?
Could you explain what the match function with the grades is?
What the match function does? So the match function, okay, so up here, so before I rename the rows, okay, So this is what info does. Okay. What match does is it just says, so grades is a vector 1, 2, 2, 3, 1. It just says, okay, what match does is we take this vector grades, and we're going to say, give me back the rows in info that correspond to 1, 2, 2, 3, 1 in the grade column. So I say info $grade, okay? And it's going to say, okay, if you want the row where info grade is equal to 1, you want the third row, okay? I could also do like match poor, okay? Info $description, okay? And this will give me, you know, which row in info matches description poor, okay? It's going to say, oh, that's the third row, okay? Whereas if I say say this, it's going to say, oh, I couldn't find a match in the description column, okay? Right, like that. Okay. So we have that. We can do random samples, all right? So over here, I'm going to create a data frame with 6 rows, okay? So data frame is just this nonsense thing, okay? So here I've got 6 rows. Y goes 6, 5, 4, 3, 2, 1, and Z goes A, B, C, D, E, F, okay? And things like that. I can shuffle these rows, all right? I can do sample 6, okay? Sample 6, or sample, over here it says number of rows df, which is 6 rows. Okay, sample 6 just says take the integers 1 through 6 and shuffle them, okay? So sampling 6 just takes the numbers 1 through 6 and shuffles them. And then so if I do this, here I'm subsetting df. Oops. And I'm getting, we're asking sample 6, basically, all right? Or I can do number of rows df, which is 6, okay? So take these numbers. So the first, after doing set seed 10, it's going to go 4, 2, 5, 3, 1, 6. That's how it shuffles those numbers, okay? And so it's going to return 4, 2, 5, 3, 1, 6, and it gives me, you know, D, B, E, C, A, F, okay? So we're just shuffling the rows in a data frame as such, okay? Because all we did was shuffled the numbers 1 through 6, and then we said R, find the matching rows. No problem there. Okay, if we wanted 3 rows, we can just say sample 6, comma 3. 6, comma 3 basically just gives you, you know, the first 3 numbers from the sampling 6, okay? And so if I run this, it will just give me 263, okay? And it says, you know, the arguments of sample control the number of samples to extract and whether sampling is performed with or without replacement, okay? In bootstrapping, which we'll cover later on in our course, you sample with replacement, okay? So, so sampling without replacement is you put the numbers 1 through 6 on a piece of paper, you put them in a hat, and then you draw them out, right? Once you draw it out of the hat, it's no longer in the hat to be drawn, okay? With replacement means you put it back in, then you mix up the hat, and you draw it again, okay? Or like rolling a die, you can roll the numbers 6 multiple times. So if you do sample 6 replace equals true, here I happen to roll the number 4 3 times and the number 3 twice. Okay. All right, we can order things. All right. So here I've got a vector BCA. Order X says if you want to put this in order, the way you got to do it is you got to first go to the third item, then you go to the first item, the B, and then you go to the second item, C. Okay? And then so if we feed order of x into x bracket, okay, then it will go to x, pull the third item, A, pull the first item, B, and then pull the second item, C. Okay? And so x, order of x is kind of like sort x, right? So order will do that. X order of that, I could also just as easily have done sort x and as such, okay? So sort will just sort the vector. Order will tell you the positions that you want if you wanted to put them in order. Okay. We can use that, the ordering function, to then put a data frame into in order. Okay, so here I've just shuffled the rows of the data frame. So df2 now has now looks like this. Okay, CAB DFE. Okay, 4 6 5 3 1 2 and 2 1 1 2 3 3, something like that. If I wanted to put this in order, okay, I can order it on the column X. All right, so I can say order df2 $x, okay, and it will say if you wanted to put the column X in order, you would have to go to the second row, then the third row, then the first row and the fourth row, and then the fifth and the sixth row. Okay, and I can do that. And it indeed puts the column X into order 1, 2, 3. Okay, but we're only giving it X, and it doesn't recognize that, oh, maybe we wanted to put Z or Y in order or things like that, and so it doesn't. It doesn't try to do that. Okay. What would this command do? df2 comma order names df2. Okay, what is names df2? The column names, right? Names of a data frame are the column names, okay? And so here, what would order of the column names be? Yeah, so here it looks at the data frame and it would say, oh, if we want to put this in order, we would go to the third column, then the second column, then the first column, okay? And then so here, running this command would put the columns in order into X, Y, Z, okay? Whereas before df2 was Z, Y, X. All right, so let me just show you what this thing does. So this thing is called expanding aggregated counts. Okay, so here, let's say sometimes you'll get data shown this way. You've got data point 29, and then here it says this thing appeared 3 times. Okay, there's a column n. So the data point 29 appeared 3 times. The data point 411 showed up 5 times, and the data point 16 showed up 1 time. Okay, and maybe you don't want to have to deal with these summarized things, but you want to expand them out. Okay, well, we can take advantage of this repeat function. Okay, and here we're going to just say repeat 1 through 3. Okay, 1 through 3, or 1 through the number of rows in df. Okay, which is basically 1, 2, and 3. And how many times do we want to repeat this? Well, we want to repeat it. We're going to repeat 1 3 times, we're going to repeat 2 5 times, and we're going to repeat 3 1 time. We're going to use the values in column df $n. Okay, we're going to use the values in column n to create how many repetitions we want. And so we see 1 has been repeated 3 times, 2 has been repeated 5 times, and 3 has been repeated once. Okay, so I have this thing. Now that I have this thing, I'm going to feed that back into data frame. So I'm going to take this exact thing and just throw it into data frame and say, give me back the rows 1, 1, 1, the rows 2, 2, 2, 2, 2, and the row 3. And so here we get the row 1 3 times, the row 2 5 times, and the row 3 once. Okay? And so, you know, at this point I can get rid of probably column n. Okay? But now we see 2, 9 shows up 3 times, 4, 11 5 times, and 1, 6 once. Okay. All right. The other thing of subsetting is maybe you just want certain columns. Okay. If you want to get rid of a column, you just say you can null out the column. You can say $$z null, and that will just delete column z. Okay. Another way you can do it is you can just say give me back in data frame just columns x and y. Okay. Those are equally effective at subsetting the data frame, giving you back only the columns you want. Okay. And then you can use set diff. Okay, set diff is these are some set operations, kind of like union and intersection. Set diff is give me the things in here that are not over here. Okay, so if we said names df would be x, y, and z. Those are the values. Okay, those are the 3 columns that exist in the data frame. The names in our data frame are x, y, and z. Which ones are different from z? X and y. Okay, and so that's useful if you know which ones you want to get rid of. Okay. I think we're pretty familiar on this stuff. Selecting rows based on a condition. We can say, you know, I want only the rows in empty cars where gear is equal to 5. Okay, so we say empty cars $ gear equal 5, and that makes sure that this gear column is equal to 5. Okay, because when you do this, you get a logical vectors of trues and falses, and then and it's only going to return the rows that are true. Okay, and then you can combine things. You can say, I want it where gear is equal to 5. That's a logical true and false vector. I want it cylinders equal to 4. Okay, and we put the and here, and so it's only going to give you back the rows where both of those things are true, where this is true and this is true, and so we get cylinders are 4 and gear equal to 5. Okay. You have the OR operator, which is the vertical bar. Okay, and we also have double and double OR. Okay, double and only returns 1 true, or and double OR also returns only 1 true or false. Okay, whereas single and single OR are vectorized, meaning if you this is a vector of trues and falses that and there's 1 for every row, right? So if empty cars has 30 rows, there's going to be 30 trues and falses here, and then there's 30 trues and falses here. And the single and compares, the first true and the first element of the logical vectors and says, are they both true? Yes or no? Okay, and it goes through and it goes element wise down the vectors, which is what you're going to want to be using when you're doing trying to subset using logical vectors. Okay, we got De Morgan's laws. And you probably learned that during your probability class. All right, subset is kind of like a shorthand for this. So instead of, you can subset this way, totally fine. You can also use the command subset, where you just say subset empty cars where gears are equal to 5, and that works. Okay, and then you can throw in multiple condition, that also works. All right, and then we have Boolean algebra, which is your true and false, and those combinations of those things. And then we have sets, like 1, 2, 3, and things like that. So Boolean algebra is used for the logical subsetting. Integer subsettings for set operations. We'll talk about this. Okay. So here we have this command which. All right, and this one just returns the rows that are true. So you take a logical vector. Okay, and if you want to turn it into kind of set representation, so here we're just saying, which values are true, okay? And it will return you, it'll tell you, okay, the position 2, position 3, and position 10 are true, everything else is false, okay? So which values in the logical vector x are true? Okay, so x is the logical vector, which of x returns an integer vector? Okay. All right, so here is just some stuff. So x1 is taking the integers 1 through 10, and it says if mod 2 is equal to 0, is mod 2 equal 0, okay? And so here that's basically going to be false for anything in the odd positions and true for anything in the even positions, right? So if we say which values are true in x1, it will say 2, 4, 6, 8, and 10. Okay. Over here, we're just saying which ones are divisible by 5. Okay. So it's false for 1, 2, 3, 4, true for 5, false for 6, 7, 8, 9, and true for 10. Okay. And which values in y are true, then we get 5 and 10. Okay. So x will be the even positions, and y will be the divisible by 5 positions, okay? And then x1 and y1 are logical vectors. x2 and y2 are the integer representations of those things, okay? And so we can show you kind of how logical vectors and set operations are kind of like complementary ways to conduct things, right? So if I do x and y, okay, this means both of the things in x and y have to be true, okay? So it's going to be false for everything except for the last one, which is true, all right? And that's the same as doing the intersection, okay? Intersection of 2, 4, 6, 8, 10, and 5 and 10, the intersection there is 10, okay? The OR over here is the same as the union, okay? So here it's going to give us false, true, 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 false, true, okay? Or union of 2, 4, 6, 8, 10, and 5 and 10 is this, 2, 4, 5, 6, 8, 10. Okay. Here's some more of these things, okay? The things that are in x and not y, okay? So that's equivalent to set difference, set diff, okay? So it's going to be the things that are in x but not y, so 2, 4, 6, and 8, okay? The 10, because we've negated the y, is no longer part of it, okay? So these are things in x that are not in y, okay? And then here we have exclusive OR, okay? Exclusive OR, maybe you guys are familiar with this. This is, so in English we only have one word for OR, okay? And we use it in the inclusive and exclusive way. And from context we know what we're talking about. But so if I said, if I asked you the question, do you like chocolate or vanilla ice cream? Your answer would be yes, I like that. Okay? Or no, maybe you're lactose intolerant. That's the inclusive OR, okay? It's if you happen to like chocolate or vanilla or both, then you say yes, okay? On the other hand, I could ask the exact same question, just emphasize it a little differently. I could say, do you like chocolate or vanilla ice cream? And then now your answer is, I like chocolate, or I like vanilla ice cream, something like that. Okay, that's an exclusive OR, meaning it's you're allowed to like one or the other, but you can't like both. Okay, that kind of thing. And so here with the exclusive OR, if both are false, it's going to be false. If one is true and one is false, that's going to be true. But if both are true, then it's false. Okay, and so with the logical, we can just say exclusive OR and it works out, and we go, okay, all of these things will work. So we get 4, 5, and 6, but then the 10, which is in both sets, is going to be false. Okay. to do that using set operations, it gets a little complicated. You do the, what's the difference between the union and the intersection? Okay, and right. So you think of the Venn diagram. You've got the union, but then you're essentially removing the intersection, and so you'll just get the whatever this part is, right? The double moon. Okay.
So can you explain again what the context of exclusive? It kind of just like passed me.
The exclusive OR.
Yeah.
So
in this context.
So in this case, it's what numbers are divisible by 2. Is the number divisible by 2, or is it divisible by 5, but cannot be divisible by both 2 and 5? That's why the 10 is false. Yeah.
Okay, that makes sense.
Okay. All right, and then so don't do this x which y, because that basically does nothing. Okay. Just use x bracket y if you're going to try to subset it that way. And then another thing, if you do x negative which y, okay, that's not the same as x not y, okay? Because if y is all false, which y will return integer 0, and negative integer 0 is going to be integer 0. So you're going to get no values instead of getting all of the values, right? Okay. And I guess over time, I think you'll probably develop a tendency to favor one side or the other, whether it's set operations or logical operations, okay? I think, in general, my brain has come to think a little bit more quickly in Boolean algebra with the logical trues and the falses, and combining that with the ands and the ors. So I have a tendency to write my code that way. Other people will write their code using set operations. Okay, give me which rows are this, and intersect that with the other things, or union or things like that. Nothing wrong with either way. You'll probably develop a tendency for one or the other. Okay, or maybe you'll use them both interchangeably. Okay, no problem. They're both valid ways to select things. Okay, let's talk about programming. And so the first thing is you want to make sure you're saving all of your files in your working directory. Okay, it's very simple. You can just type in get working directory, and that will tell you where your current working directory is. Okay, you can say get working directory, and this currently I'm in my lectures folder. You can always set your working directory. You can type it. You can put this in your thing using set working directory, and then you'd have to type in some kind of path. Okay. You can also in RStudio do session and set working directory to any of these things. Choose to the source file location, or choose the directory. Okay. Another thing is you can start using projects. Okay, RStudio has implemented projects, which I think is a great way to do things. Okay, so it probably makes sense to create a project folder for homework 1, a project folder for homework 2, or homework 3, or something like that. And then so you go to File, New Project, and then and what it's going to do is it's going to create a directory for that project. All of your files related to that quote project or activity that you're working on go there. Okay, and then so when you open up the project, it automatically sets your working directory, and so any new files or anything that you create is going to get thrown into that directory. Okay, and then you can throw all of your data files into that directory, and then so when you call and you tell R to load up a data file, it knows exactly where it is. It's in that project directory. Okay, so you can RStudio use projects, or you can you can put the paths in there. Okay. Clearly, as you're writing code, you can add comments by using the hash symbol, #, whatever you call it. Okay, and so you do that, and the things after the pound do not get executed, right? and you can disable lines of code that way. All right, we can clear the environment. You can say, you can check what's in your environment by doing ls. Okay, you can also, in RStudio, they have the environment section. The environment normally appears here and your console is down here, but I've switched it around so those in the back can see the console. But there's like this little broom. You can do that, and that will delete everything in the console. Okay, I mean inside the environment. And then when you call ls there, it's going to say character 0, meaning a character vector with 0 entries in it, right? The other thing is you can do rm list equals ls, and so it's going to go through. It's basically saying take the names of everything that's listed in the directory space and then remove all of those things. Okay. Yeah, writing scripts. I think you guys know this. All right. All right, so we have our logical operators, okay? We have or and not. These are all vectorized, meaning you can give it a vector of true false values, okay? Like 10 of these or however many, 1,000, okay? And then if you give it 2 vectors, it will go element-wise. And if it runs out on one vector, it's going to recycle it to match the longer one. And it will go element by element, doing the comparisons that way. True or false, true and false, things like that. Okay. Whereas the double or and the double and, these are not vectorized. These require only look at the first element in each vector and will only return one true or false value for the double or. Okay. So that's what we have. Exclamation means not. Okay. And numerical vectors will be coerced to logical values if you throw it in there. Okay. 0 is false, and anything that's non-zero will be true. Okay. So we have this x or y, true, true, false, true. The double or only looks at the first element and will give you true. Okay. X and y, it'll go through these. Which ones have both of them being true? And that's only the second element. Okay. And x double y only looks at the first thing in x and the first thing in y. The exclusive or we've already talked about. And then there is a statement called is true. All right. And that's a abbreviation of identical, true, and x. So that's true if and only if x is a length 1 logical vector that has no attributes and is true. Okay. So if we asked if this thing, if x true, true, false, false is true, that's going to say it's not. Okay. Here we have some comparisons. Okay. We have less than, greater than, less than or equal to. Are they equal? Not equal, or is x in y? Okay. And so test for equality. This is just one thing that we have to be careful about. Okay, so all right, if I do 0.1 plus 0.2, what is r going to return? Okay, 0.3. That's not a trick question here. All right, so let's say I say x, we're going to store as 0.1 plus 0.2. Okay, so I have x, right? X is 0.3. Okay, if I do x is equal to 0.3, what will this return? False. Okay, what's going on? All right, so this was a little bit of a trick. All right. Okay, so this is essentially what's going on, and we'll talk about this a little bit more when we get into numerical stuff. But let's say I ask you write 1/3 in decimal form. What would you write? You'd write something like this, right? 0.33333333. Okay. In math, we can write like a little bar over the last 3 to say like it keeps going on forever, but in a computer, it doesn't understand that, right? So it's storing this, okay? And then I say, okay, take that and multiply that by 3. Okay, I say take this and multiply by 3. What's your answer? It's going to be this, right? And then and essentially the question is this equal to 1? Okay, and the computer is basically seeing this, and it's going to say no, they are not equal. Okay, whereas, you know, because we have math, we know, oh, what we have 1/3 multiplied by 3, that's 1. 1 is equal to 1. We know that, okay? But the computer doesn't understand kind of infinite decimals, and so it has this finite decimal representation. And basically, when it's representing 0.1 in binary and 0.2 in binary, you're getting just kind of this little mismatch at the end, and it doesn't recognize that it looks like 0.3. Even though on the computer it looks like 0.3, it's just these are not the same, okay? So we have some workarounds here, okay, right? And then if I say, you know, square root of 2, and I square that, it looks like 2, but is it equal to 2? No, okay? This is the thing that's going on inside the computer. Right, all of the rules of math kind of like they break down a little bit inside when you're only allowed to represent a finite number of decimal points. Okay, and the computer has no history of the math operations that got you to this finite decimal representation. Right, so you kind of have to think of it that way. Right, we're representing a number in a finite number of decimals. We have no idea how we got here, and then we're doing operations on this. So, okay. All right, so the most important conditional ever in programming is the if statement, okay? It's going to say run this code only if the condition for the if statement is true, okay? And if it's if that condition is true, then the stuff in the curly braces is executed. Otherwise, the stuff in the curly braces is not. Okay? The if only expects a logical vector of length 1. If you give it a logical vector with more than one thing, it's going to just look at the first element and also say, are you sure you know what you're doing? And it's going to try to coerce things into logical if they can. Okay, so anyway, let's... and then the curly braces, if there's only one expression to execute, the curly braces are optional. Okay, so over here I say x is 1 and 3, and then we're going to say is 1 in x, that is true, okay? And then so we say if 1 is inside x, which is true, print hello. And it goes hello, and that's it, okay? And because there's only one thing to execute, I left off the curly braces. It's probably a good habit to always use the curly braces, okay? Unless it's like very short code that you're throwing together. All right, over here I've got the same thing, 1 and 3, okay? And then we're asking, is x greater than or equal to 2? Okay, and so it's going to say no and yes, okay? False and then true. I can say, all right, if x is greater than or equal to 2, print hello again, okay? And then so it's gonna, the if statement only looks at the first element here, and it says a false. Because it sees a false, it's not gonna print this, okay? But it's gonna say, wait a second, you gave me a logical vector and there were 2 things in that logical vector, and that's not how this works. So it's gonna say, warning, the condition has a length greater than 1, so only the first element is used, okay? But it doesn't print hello again, and that's it, okay? All right, and so instead, we can use any x greater than 2, okay? So any is like a series of ors, okay? So it's just or, So over here, this is going to be true, right? You have 20 falses and 1 true. Any is going to return back true. It's just like having a bunch of ors. So we feed this into if any of the x are greater than 2, then we can print "can you hear me now," and that's gonna work. Okay, we can nest conditionals inside each other, okay, using else statements. All right, so so if you're going to use else, you have to use the curly braces. All right, and so we have this. Okay, so it's going to go if this, and then if this is false, then it's going to go to else. All right, but if it's true, it's going to skip all over all of these other else's. Okay. You have to put else on the same line as the closing curly brace. Okay? If you don't put else on the same line as the closing curly brace, it's going to think, like, if you just, if you just end it here, it's going to think, oh, well, that thing is over, and then it's going to look at the next line, and then it starts off with an else. It's going to be confused. It's going to say, like, I don't know what you're talking about. Else what? So here we have to say if, otherwise, okay, or else. Then we can give it another if statement, and then so this thing will only be evaluated if this is false, then it will run this, okay? And so, you know, if we give it 3, it's going to say this is false, and over here this is true, so it's going to print positive, and then it skips over this. Okay, so we get positive here. If we give it 0, this is going to be false, so it skips down to here, it's going to be false. And then, so if because these two things are false, it will run this, and we get print 0. Okay. And over here, okay. So here we have this thing. We said if x is greater than 0, print positive. Okay. And then we have else if x is greater than 1. This isn't even evaluated. Okay. It's not even gonna. Because this thing is true, it's gonna skip over all of these else's. Okay. I could even put an error in here. And it's not gonna. It's not even gonna bother trying to execute it. Where did it go? Right. So like if I do something like if and I do stop, and then I say like print hi. Okay. It's gonna, you know, stop it is like an error thing, right? Okay. So if okay, so here I can do this, all right, and here I can just say if over here I can throw in the stop, okay, and did I do something wrong? Else if stop. No, maybe what I'm talking about isn't true. Let me see. Okay. Well, I guess it does look inside this if statement. So it does run something, but it doesn't. It's not gonna execute because this first thing is true. So anyway. Okay. We'll pause here and then we'll continue on Wednesday. We'll talk about loops and all of that. And so homework 2 is posted. You can start taking a look. Wrap up homework 1. It's due Wednesday. Make sure you get it in before the deadline there. Okay?